Okay, so today we're going to cover Chapter 2, Section 5. Today we're going to be writing proofs or proof statements about segments and angles. So we'll be writing our first geometry proofs. So the first thing, though, we're going to do is define what a proof is. And a proof is just a logical argument that shows a statement is true. There's various forms of proofs. You could write a flowchart proof, a paragraph proof, or what we will be focusing on are the two-column format. These will be the types of proofs that you will be writing in this class. Just like we saw yesterday, you're going to have a column that will be headed off or labeled as statements, and then your other column will be the reasons. The statements could be your given information, or it could be the result of applying that given information or unknown property or fact. And then the reasons, you will give an explanation for each corresponding statement. And what you're going to see is those reasons are going to be definitions, theorems, postulates. Now, again, like I had said yesterday, these the two-column proofs are going to be challenging at first when we start writing these geometry proofs. Now, in our textbook, they do cover flowchart and paragraph proofs. So if you happen to use your online resources, your e-textbook, and you're looking for additional proof practice, you could still do the questions that ask you to write a flowchart or a paragraph proof. Just know that you can turn those answers that you'll see there to check your answers. You could turn them into a two-column just by pulling the paragraph apart and even take the flowchart. The flowchart is just a bunch of arrows and circles, but all you're going to do is take that flowchart and organize it into two columns. Now, also on your Big Ideas website, there's a skill trainer that has practice problems for the lessons. Sometimes some of the lessons that involve proofs, there will be additional proof practice in that skill trainer. So, try to use the resources available to you, especially when we're starting to write these proofs. So the next slide, these are all acceptable reasons in a proof. So when you have your given information, the reason will be given, but the given could be spelled out for you, or you could be pulling the given information from the diagram. Sort of like what I did yesterday when we looked at that picture and I saw the congruency marks on the angles. But generally on a test or the quiz, I'm not going to make you pull the given off of a diagram. I will tell you what's in that picture. Now, not always will I give you a picture. It may just be the typed out given and prove. Now, also acceptable reasons will be definitions, properties, postulates, and theorems. Now, what I mean here by previously proven theorems, I'm talking about the theorems that I have taught you. So right now we're in Chapter 2. So any theorem that you might have learned in Chapter 1, which we haven't learned any yet, we're going to see our first ones in this chapter. But any theorem from any prior chapter or any definition or property or postulate can be used in the current chapter. So I need to have taught it to you. So right now we're in Chapter 2. You can't pull a theorem that's listed in Chapter 10 and put it as a reason in your proof, because I haven't taught you Chapter 10 yet. So the biggest challenge you're going to find with geometry is all of this information is cumulative. You can't forget anything you've learned from a prior chapter. All right, so a theorem is just a statement that can be proven. And the way that you'll prove it is using deductive reasoning. These are the first two theorems of Chapter 2. Notice the numbers on them are 2.1 and 2.2. Just like with the postulates, we're not going to memorize the numbers because these numbers, again, are specific to our textbook, and it's not like a standard number that's assigned to this specific theorem. So the first theorem is called the properties of segment congruence. And segment congruence is reflexive, symmetric, and transitive. So these three properties that we learned yesterday, how we applied them to algebra, you can now also apply them as a congruence versus a property of equality. So same properties, and we're going to see them on the next slide, but now what will be different is instead of an equal sign, it's going to have a congruent symbol. And then the same thing for the properties of angle congruence. The properties of reflexive, symmetric, and transitive, in addition to being properties of equality, now they're also going to be properties of congruence. So yesterday we saw a similar looking chart, but notice now what's different is the symbol in between. And now instead of equal signs, now it's got the congruent symbol. So for here, these are all properties of congruence, not of equality now. And again, remember this column, these were the properties listed. These are segments examples, and these are angle examples. Example using angles. So remember the reflexive property was like that mirrored image, the reflection. So it's the same thing equals the same thing. For the symmetric property, remember that's where it reverses the order, sort of like commutative or like a line of symmetry. So if DE equals FG, then FG equals, congruent to DE. So again, same thing as before, the only thing we're changing now on these examples is now it's got a congruent symbol. So before, when we talk about things being equal, we're going to probably be given the measurements, and we'll show numbers equals numbers. Whenever it's a congruent symbol, I don't care how long it is, I just know that they're going to be the same length or the same measure if it's an angle. Just like before, I abbreviated property of equality as POE. If you want to use the abbreviation of POC for property of congruence, you can do that. Now for these three properties, as long as you write the word reflexive or symmetric or transitive, I don't necessarily need POE or POC at the end. Just writing this word, reflexive, symmetric, transitive, is enough as the reason in the proof. So let's go ahead and take a look at our first example, which is a geometry proof. All right, so this one wants us to write a 2-column proof. So they've already set it up. The lines here are in white. They're hard to see. Let me go over them in yellow. So we have our statement column, which was given to us, and now we have to come up with all of the reasons for these statements that they've given us. So again, remember that first statement is what you're given, and the given was right here. So they wrote AC equals AB plus AB. So this reason is given. So when you begin writing your own proofs, don't leave off step number 1. Let's say you get to the test and you're like, you look at this question and you're like, I have no clue what to do. What you need to do is not leave it blank. What you need to do is at least give me the first statement and reason, because it's going to be given to you up here at the top. And then another thing you can include without even knowing what to do in between is also the last step of the proof will be what you're trying to prove. So I was trying to prove that AB equals BC. So just by putting in these 3 things, you've gotten some points for this question. It may not be a lot, but it's something. So don't leave a proof totally blank. At least get it set up with the headings, statements, reasons, put in that first piece of given, and what you're trying to prove. Then go back and see if you can figure out what it's going to take from step number 1 to make it to step number 4. So what I need to do, what I always look at, is I try to see what I'm trying to prove. And notice what I'm trying to prove is AB is equal to BC. Now, right now, the only thing in my given is AB. I don't have anything about BC yet in my given information. So somehow I'm going to need to bring that into my steps of my proof. So I'm going to go ahead and notice what's happening here. So they're telling me that the length of this whole thing, AC, is equal to AB plus AB. So what I'm going to do now is my next step, I'm going to look to see what it looks like. And it looks like I'm taking this little piece here of AB and adding it to this little piece here, BC, and then they're telling me it equals the whole length of AC. If you remember back from chapter 1, we learned that when you take two little pieces and add them together to make one larger segment, this is called our segment addition postulate. This is going to be the postulate that justifies what we did in statement number 2. So this is the segment addition postulate. And I'm going to abbreviate that as SAP. Now you can either abbreviate it or you can write it out. It doesn't really matter. So this is what they did in step number 2, is applied the segment addition postulate. Now we have to look to see what changed from step 2 to step 3. So if you notice over here, they have AB plus BC, but then in step 3, they also have it over here. What changed is AC, and they made it AB. But if you remember, up in step 1, they told us that AC equaled AB plus AB. So what they did was a substitution. They took out AC and they replaced it with what was given, that AC equals AB plus AB, and that's what they put in place of AC. So this example, or step 3, is substitution. Then now we have to figure out what did they do to go from step 3 to step 4. So for step 3 to step 4, notice what changed now is they took away an AB from both sides. So to go from 3 to 4, what they did here was they subtracted AB from both sides of the equation, leaving us with AB equals BC. So that process of subtracting the same thing from both sides is your subtraction property of equality. And again, if you just put subtraction, I'm okay with you just putting that versus POE. However, look for it in big ideas because they will probably have the words property of equality after the word subtraction. All right, next one wants us to write a 2-column proof. Now, notice on this one, the given information is M is the midpoint of AB. So again, remember, that's your first statement and your first reason. The reason is it was given to you. Now, on this particular problem, notice they're asking us to prove 2 separate things. I will never ask you on a test or a quiz to prove two things within the same question. So this one I'm just going to show you that you'll do the first proof, the A part, but then all you need to do is take it one step further to get to the B part. However, on a test, maybe one version, your question might be to prove AB is equal to 2 times AM. On another version, it may be AM is equal to half of AB. So it may be a different proof based on your version of the test, but I will never ask you to prove two different things within the same question. So let's go ahead and see what they've done. So since they told us that M is the midpoint, I know that the midpoint splits my segment into two congruent pieces. So that is split AB into two little smaller pieces that are congruent. And notice that's my next statement, that AM is congruent to MB. So my reason here is the definition of midpoint. That's what I applied here. Now, when you're writing these reasons, you have to specify whether you're talking about a definition or a theorem or a postulate, because sometimes it's the definition, sometimes it may be the theorem that applies to it. So generally the definition is going to tell you how it's created or what it does. Generally, the theorem is going to tell you about the value of whatever it is you're talking about. The next one, we got to look to see what did they do from 2 to 3. Notice the letters are the same. What they changed here was the symbol. So this is where that theorem we just learned, or the definition, when they change it from a congruence to an equal or vice versa, equal to congruence, all you have to do is put in that it's the definition, and I'm going to abbreviate definition as DEF, of congruent segments. Now the next one, we got to look to see what did they do to go from 3 to 4. Or maybe they're bringing in just something else that's applicable here. Now remember, all they started out with was M was the midpoint of AB. Notice in my proof, I've got an AB and an AM. So I need to get, some of these other things in here. I need to get AB into my proof. So what I'm going to do in step 4, and it's not doing anything to the step above, but I'm going to bring in the segment addition postulate again. And I can show that when you add AM plus MB, it's going to equal the whole segment of AB. And that's what they did in step number 4. So they used their segment addition postulate. And I'm going to abbreviate it SAP. You can write out the word segment addition postulate if need be. Now, for 5, this time I'm going to look to see what did they do from 4 to 5. Notice the only thing that changed was they changed MB to an AM. Now, if you remember, they told us MB equals AM. So that's what they did. They substituted AM for MB. So this is a substitution. And now, from step 5 to 6A, all they did was simplify, combine like terms. They added the 1 AM plus the 1 AM, and that's how they got 2 AM. So for step 6A here, it's simplify. You can also describe it as or combine like terms. And then for the last one, step 7, all they did here was take step 6 and divide both sides by 2. So once you divided this by 2 and this by 2, that's how they got the 1/2 AB. Now, you could also have thought of it as multiplying by the reciprocal, but technically it is the division property of equality. Or probably big ideas would look for division here. However, I would also accept multiplication if you want to think of this as multiplying by the reciprocal. All right, and this last slide is just a little summary. So when you're writing a 2-column proof, you're going to make one statement at a time until you reach your conclusion or what you're trying to prove. You're going to be making your statements based on facts, using deductive reasoning, and usually the first statement is going to be what was given to you, whether it's spelled out or from a diagram, and the reason is given. And then from there, your proof must flow logically. So here, they're telling us that angle 1 and 2 are congruent, and they want to prove that angle 2 is congruent to angle 1. So here, all they're doing is showing that symmetric property where they reverse the order. So again, it must flow logically. If you're given a whole lot of information and you don't want to list all the given until you need it, you can also do it that way. I always like to put my given all up at the top. That way I don't ever forget to include anything. So again, it must flow logically. And that is it for the notes.